I should move my crown a little bit. Hello, everyone. I'm really glad to see you all here, and I'm glad to open our today's Tableau user group. My topic will be quite technical, I suppose. Target audience is those ones who work with Tableau quite regularly and familiar with table calculations. It will be more in the format of a workshop. So if you have any questions or want me to clarify something, feel free to ask. If it will be quick, I will answer immediately. If not, I will postpone it till the Q&A session or break or networking part. I will show a lot of examples in Tableau desktop. So if you wish, you may download the workbook right now. But I suggest just to listen and watch, and then if you miss something or want to go deeper into some cases, you may download it from Tableau Public and check. First part will be about compute using. So it's how to set up table calculations on your view. Compare table SQL to make it easier to understand. Then speak about how to manually set direction of calculation. And I will start with one outcome. Presentation just started, but I already want you to see this idea and to keep it with you when you go home. Table calculation, its result is defined by two parts. First, calculate, and compute using. That's how you set order direction of calculation on your view. So, for example, one calculated field may return different results if you compute it in different ways. Let's go into Tableau desktop, and I will show it here. First example is quite basic. I think it's one of the popular usage of table calculations is calculating top n elements. So, for example, we have list of subcategories. I want to order them by sum of sales and show only top 3. Who did something similar in your experience before? Yeah, good. Here, I use two calculated fields. First is rank, which is enumerates my subcategories. Table calculations work the following way. First, Tableau calculates like simple aggregations on each mark, and then rank. It is a table calculation. It is another layer, another aggregation above pre-calculated arguments, like rank function in SQL, for example. It works pretty the same. And the next field I use is собственно, filter by top 3. I use rank from the previous step and leave only 3 values. Compute using. When you put table, you can set a computation. Table down, pane down. So here I use table down. It means that Tableau goes into one partition across all marks on my view. Let's see a little bit more complicated example when we have 2 dimensions. And now I want to show top 3 subcategories within each category. so without filter, only for each category. I use absolutely the same rank function, but I go into compute using, and let's look what we'll have uh, if I show it table down. You see rank enumerates all marks in partition. If I use pane down, for example, Tableau calculates ranks independently inside each pane, inside separate categories. Let's have a look, a comparison with queries. So for example, when I make compute using pane down, or when I manually click or we can link in SQL like this. Select category, subcategory, category, sum of sales, like simple aggregation, and rank, it's a window function, which is calculated above pre-calculated total sales and partitioned by category. So it's quite similar in Tableau. Let me show one more time. When I go to edit table calculation, here we have basic built-in compute using like table down, page down, but also have specific dimension. When I started to work with Tableau and didn't know how it worked, I was just clicking it randomly, unsuccessfully, trying to understand how it works. Who did the same? Who did? Yeah. So now I will share the secret how it works. It's not visible into interface. Actually, when you fields, you split them into two groups. Select. They goes into partitioning, meaning they split your marks into separate partitions, isolated from each other. And others, which you tick, which you select, they go to addressing, meaning that Tableau will calculate along these fields. Let's go to the next example. Difference from. Imagine I have the following table with sales for each quarter. And I want to calculate difference from previous quarter, like Q4 minus Q3 plus something, and difference from the same quarter but 1 year ago. So Q4 24 minus Q4 23. I use one field for both calculations. Let me show the formula. So it's sum sales, which is calculated on each mark, minus lookup minus 1. Lookup is a function similar to lead or lag in like PostgreSQL, which can go like one or several steps behind or further in your partition. So one formula, but I use different compute using. Difference from previous quarter, it's table across, or in terms of specific dimensions, I select both year and quarter, meaning that I don't have several partitions. I have only one partition, and I go through it and calculate lookup minus 1 from previous mark. And for another, it's more tricky. I split my view by quarters into isolated partitions and go along the year. So it's like we split it into quarters and make one step back. And again, let's compare it with query sample. When it's different from previous quarter, we have only one partition and go order by year and order by quarter. So no partition by. When we want difference from previous year, so partition by quarter, order by year. You may check how it works in Tableau, may check how it looks in your database. So probably the results will be the same. Okay. Now I think I'll go to the next part. But again, before one more outcome. So how to remember what these checkboxes do? If you do not select a field, a dimension, it goes to partitioning and divides data into isolated slides. If you select dimension, it determines the direction of calculation. So which field you go first, which next. Any questions maybe? Very intuitive. Now or before? Yeah, yeah, I understand. Yes, actually, I think I found out it not from Tableau knowledge base, but from some articles of enthusiasts, and it really helped. Okay, next, total. I really like this function. I think it's the most popular table calculation. I use it quite regularly. And the most popular example, if calculating mark, and for denominator, you want to calculate total across several marks. The interesting part of total is that it works differently from other table calculations. I will compare total with window functions like window sum, window average, and I will compare it with LOD, level of details calculation. My understanding of total, the message, that total works more like an exclude rather than a table calculation. But total was available much before LOD appeared. So I am from the era before LOD, so I really like total and do not like LOD. Who is a LOD person? Who is table calculation? Who prefers LOD? I see. Unfortunately, some of my colleagues. I should talk with you strictly. Okay. Just kidding. So, for total, imagine the following table. We have some categories and want to calculate how many unique customers made at least one order from this category, and then calculate percent of these customers from total client base. The question, how to calculate total client base. Window function aggregations on each mark and then make like second calculation above these marks. So if I calculate window sum of count of customers, Tableau just calculate with these numbers, which is not correct because we may have intersections. One customer may have orders from different categories. The correct answer will be using total. Let's look at total function. Total itself doesn't have specific aggregation like window sum, window average. It's just total. it breaks your detailization and calculate initial aggregation from its argument like we didn't have split by dimension. So if I remove all dimensions, total will be 800. If I return it back, total will be the same. Let's look at compute using. Yes, table down, meaning we have only one partition and we calculate total inside this partition. So yeah, total ignores your level of details and calculate row level data inside partition, which sounds similar to what exclude does. Let's now compare total versus level of details calculation. So one total calculated using table calculation total, one using exclude. So instruction for Tableau is exclude category from the view and calculate count of customers as if we didn't have any split. So it also return 800. And the third one fixed. Instruction for Tableau for fixed, it's like fixed ignores absolutely everything, all dimensions on your view, and only calculate, aggregate data using only specified dimensions. In my case, I want to calculate the whole client base, so I don't need to fix it by any dimensions. So we have three options how to calculate total. Now it returns the same numbers. Why? Because of we don't have additional limitations. Let's look at order of operations. Who knows similar pictures? Yeah. I suggest before dimension filters, so dimension filters do not affect it, and exclude in the middle. So if we start to adding additional conditions, these results may differ. For example, let's filter only one category. You see that these totals remain the same, or not remain the same, but recalculated inside category. But fixed still show the same result. Why? Because dimension filters do not affect fixed LOD. Sometimes it's really required behavior. But sometimes I see that people used fix, apply filters, and then make these filters, make them context filters. So context filters affect fixed LOD. I do not suggest such approach because you apply unnecessary complexity to your workbook. So since you make such approach, you need to put all your dimension filters in context if you want them to affect LOD calculations. I think that's all I want to say about total. Of course, there are a lot of nice examples more, but I have limited by time. Any questions, additions? So I go to the, first of all, yeah, I already told about my preferences. I prefer total. Sometimes I use exclude. And I tried not to use fixed at all unless it's really needed by the design of my workbook. For example, when I want fixed not be affected by dimension field. And outcome for this part, what remember about total, that it ignores and aggregates its argument across all row level data within the partition you set for it. Roughly speaking, it behaves similar as exclude LOD. But of course, in different conditions, based on order of operation, you may get different results. Okay, next part, previous value. This is, unlike total, this is super rare function. Anyone who used it before? Once. I remember I used it only once in Exness during last 4 years, and once I consult my colleague about how to use it. The best way to I think it's to come -1 previous value, but we should understand previous value of what. And also I will show you one example illustrating that previous value works with text well. And this is really funny. Sometimes I use it. Maybe it will be useful for you too. Okay, let's go back to Tableau. The following example. I have a time series of a price, but it has gaps. Maybe some data is missing, maybe markets were closed and we don't have data. So I want this chart to look like this. So to fill gaps with last available value. I can do it using previous value. The formula is the following. If null, it works like coalesce in Postgre, I think. We take first argument, but if it's null, if it's empty, we take the second argument. So we go across partition, across all dates, take data. When we miss data, instead of price, we take its previous value. The question, why we can do it with lookup -1? Let's check it in the table. What will be the difference? Look at these two fields. First, price, like simple aggregation, and then lookup, -1. Table calculation, which takes value from previous step in partition. But it takes not previous value of itself of a calculation. It takes previous value of argument. So you see it's just shifted one step ahead. And if we repeat the same calculation using lookup, so we'll take price when we have it. When it's empty, we take the previous argument, lookup price -1. But if we have several gaps in a row, we still continue to take the previous result of an argument. So it can take only one previous step, not the whole history. And here is the main difference how lookup works and previous value works. Because previous value is like self-referring function. Previous value take previous value of the whole calculation of itself, not the previous value of argument. And main idea to remember about previous value is that it's self-referral, kind of a recursive function, unless as a table calculation, meaning that previous value refers to the previous result of calculation, not the previous result of an expression argument, but the whole calculation. I think that's all you should remember. In case you realize sometimes that you need something iterative, like to refer data from the previous calculation step, you should remember about previous value, and then you can Google and maybe find your solution for your case. And now, funny practical example. Imagine we have some dashboard, we have filter where we select some values, and I want my users to see the whole list of chosen values. Actually, we have a built-in function. For example, we may ask Tableau in caption or in title to show the chosen filter. But it will be work as follows. It will show 1, 2, 3, and some more. And if we select all, it just say all. So sometimes it helps, but if you want fairly to show all chosen results, we can make it custom. Let's go to this worksheet. I will break it and quickly build it from scratch. So first of all, we have a list of all subcategories and we have a filter, which applied to multiple worksheets. Now we add the following calculation. We ask Tableau to take on each step, take previous value, which you accumulated before, plus add subcategory. What this part do? Its default value. When we are in the first mark of our partition, we'll take this empty set. We can write something here, and you see it will be added as a default. In my case, I don't need it. So moving from start to the end of my partition, I accumulate the list of all subcategories. And at the end, at the last point, I have the whole list. Now I want to show only this mark. If I just filter it, sorry, keep on, calculation will break. Why? Who knows? Because of order of operation. If we apply dimension filter, it affects table calculation. So we need to filter it somehow after table calculation. So the idea, Tableau calculate the whole result, and then we filter. For this, we may use the following trick. There is a table calculation last, which return us, it's enumerate all points, all marks on the list. So 0 is the last mark in partition, and then it's increased. We go back. So if we apply last equals 0, it will be true only for the last mark in partition. And now, if we ask Tableau to filter by last equals 0, we'll get only one last mark, but we'll keep our table calculation, because table calculation filters applied after table calculations and do not affect them. So that's the way how we may generate a list of text values. I think sounds quite nerdy. Thank you, Andrei. The last part, and you are free. Last but not least, nested table calculation. It's really quick and easy, but sometimes it is missed because again, not very visible from interface of Tableau desktops that we have such opportunity. The idea at this is table calculation called nested. And for these nested calculations, we may use different compute using. For example, we may first calculate % of total for each year, meaning table down across regions. And then we may calculate % difference above these percents going table across. The idea here is to keep these nested table calculations in different calculated fields. So if we put it into one formula, we can't set different directions. Let me show. The first one, percent of total, it's just sum of sales divided by total of sum of sales. And difference to previous, it's like percent of total calculated for each cell minus lookup minus 1. So we take this minus this and get this. And now the magic is in edit table calculation. So when we go to this menu, Tableau identifies that we have nested calculations inside and appears a drop-down menu where for percent of total, I may ask Tableau to calculate the table down. And then for difference to previous, I may ask Tableau to calculate the table across. That's all. Who used nested table calculations before? Nice. Now, I hope there will be more loyal to nested table calculations users. Here I have another example with 4 nested calculations, but I will not show it. You may download the workbook and reverse engineering how it works. As usual, I finish with one idea. Keep nested table calculations in separate fields. In this case, you will be able to set independent directions, independent compute use. That's all. Thank you for your attention.
Thank you very much, Vasya, for your awesome presentation. It was very useful. It's real magic with table calculations.
Magic and mystery.
Yeah. Yeah. And now we have a few minutes. Sorry. We have a very beautiful gift for you. It's
Thank you. Thank you.
and a few minutes for
Or sharing your opinions instead of questions. It's also welcomed.
Yeah. And to make things a little more interesting tonight, we have some exclusive swag for you. It's this cap from Tableau, the same like I have. And I actually received this exact hat in 2023 when I was a speaker at the very first meetup here at Portobello Rooftop. So, but the real reward was sharing knowledge with the community. And we are always looking for new speakers for our future offline and virtual meetups. So if you ever want to be a speaker at our meetups, just let me know. And now, let's see who will take this hat home tonight. Eduard.
You already have several caps, I suppose. Will you share a mic or let him cry or shout?
Thanks. I've got one question. You said you prefer to have to work with table calculations against LOD. So, have you ever tried to make this performance recording to really investigate what is the difference between LOD or table calculations in terms of performance?
Thank you. I think I didn't record and compare in case of like share some insight about it, but I had some cases when removing LOD made like overall performance better. But I may say that usually if you don't have very granular fields, like, if you don't show a lot of marks on your view, table calculation feels like working better than LOD. But there are cases when table calculations may work worse if you have a lots of marks on your view, because in this case, even if you then filter them by table, because this case then question on each mark and on is then displayed. So yeah, I don't have numbers to say for sure, but in my like feeling, usually table calculations works better. But mostly due to some limitations when users start apply a lot of context filters or using sets. I have spoken.
Thank you very much.
Thank you.
Hello, my name is
Hey.
Katerina. I have a question about gap. I saw your formula with recursive. If we have huge gap, how it will work if we have unexpected missing numbers?
You mean you mean huge in terms of on the axis, so like 1001. Yeah, in this case it will like just take the previous result, but I think you may somehow smooth this by so not taking just previous value, but maybe combine it with somehow make a coefficient to make it no, but you create partitions the same, but addressing it versa. So it will previous value, but from the back, and then combine these two. It's my idea. I didn't check it, but I think this you may like refer to previous and previous like meaning next.
Okay, thank you.
Thank you.
Point.
Who else have questions? Who wants the hat?
Sorry, just a small comment on that previous value thing that I think we might need to use it thoughtfully, because sometimes maybe it's more important to really just see the gaps rather than just just to make graph look nicer.
Yeah, sure. In this case, it's just like an example to show the functionality.
Thank you.
Yeah, thank you for a brilliant presentation, actually. The question is some kind of out of scope a little bit. When you understand that you have to stop writing a code inside calculated field and make the calculation on the level of a data mart instead. For me, it's kind of pain, in some places. I understand that I make calculated field, then it's kind of 50 rows of code. It's better to move it to like SQL or Python or something, or DAC or Airflow or something.
Yeah. Thank you. I may say that, for example, if I would like to make this example with gaps, I would prefer to fill the gaps not in Tableau, but on data level. In general, speaking about any cases, there are two ways, I think. When I make something, so the question, when I decide, how I decide to split, the guideline. If it's something quick, MVP, when I need something quickly, I prefer to take data immediately and then start working in Tableau because it's quicker. But if I understand that I make a solution for a long-term usage, in that case, I start move as much calculations from Tableau to the data. Ideally, in Exness, we try to have like one source table, one data source, one data. It's more, it's just aggregations like sum, average, or sum divided by sum, because you can't calculate non-additive on a data level.
Thank you. Anyone else?
And another one, do you actually rely on LLM like Copilot or something to create a calculated field based on example? For my side, sometimes I have legacy kind of disaster legacy, yeah. And when I take like SQL code and say make calculated field from it, it do something, it makes something really complicated and it works, yeah. But and sometimes I'm stop myself from doing that, understanding that it's kind of black box. Do you use it?
Actually, no. For Tableau, not yet. It's for me. It's quicker to write it by myself. In our team, we try to use AI to write SQL, but again, as I know, it's like can generate something and then again human check it, review, and then merge if it's okay. But with Tableau, I personally didn't try. While I was preparing to this presentation, I asked Tableau some cases about Tableau, and Gemini provided me some examples. I checked them. One was correct, one was incorrect. So again, it's like human should touch, should check.